Afternoon, students.
Hello, sir.
Afternoon, sir.
Good afternoon, sir.
Good afternoon. All right, so we're still on the statistics. And we're going into, as you can see on the screen, we're gonna look at statistics of ungrouped data today. Might start the introductory part of the grouped data. All right. So coming back on statistics on Sunday for sure. And then we're gonna put it all together on Monday, and even do a comparison of the three areas of statistics: raw data, ungrouped data, group data, and how we deal with each thing in each one. All right. So let's get with the ungrouped data and see what that is all about, right? So that's with the raw data. I'm gonna do ungrouped data now today. So I'm gonna come off camera and we get cracking. Alrighty. All right. So statistics of ungrouped data. Keyword is ungrouped. Data is not grouped. Raw data is when you have a small number of values, like 8 values, 10 values. You can just line them out side by side and do statistics with them side by side. When do we have the need for ungrouped data? When is it possible for us to do statistics with data and leave the data ungrouped? And ungrouped statistics of ungrouped data is an exact. Statistics of raw data, the calculations tend to be exact. The statistics of ungrouped data, the statistics also tends to be exact. Right? So we're doing exact calculations when the data is ungrouped. For group data, the data tend to be estimating our group data, and we're gonna soon look at the reason for that. All right, so let's look at it now. So when the number of different observations is small, you have a small number of different observations, but the frequency of the observations is high, it becomes convenient to prepare what we call an ungrouped frequency distribution table. So put the data in a table, but we'll leave the values ungrouped. Why can we leave the values ungrouped? Because we are dealing with a small number of different values, right? But because you have a large number in terms of the frequency, right? You're not able to list them side by side. So let's look at an example. That's an example. Let's say we'll call it that raw data. And let's say this is a count of the number of children in families. I was saying that as an example. So what it is that there are 2 families with no children right there. And then there's 1, 2, 3, 4, 5 families with 2 children. So you go into all these families and you're asking them how many children in this family, how many children in this family, how many children in this family, how many children in this family. So you go to all these number of families. So you see that the number of different observations is small because it's only 0, 1, 2, trees, the trees here. These are the trees over down here as well. Trees and 4s. So you have 0s, 1s, 2s, 3s, and 4s. So the number of different observations is small. But the problem is that they appear in high frequencies. So for example, the frequency of the 4 is large. There's a lot of 4s there. Similarly, the frequency of the 3s also is large. There are a lot of 3s there. And then you also have the frequency of the 2s, right? Frequency of the 2s and so on. So the frequency of the values are high, even though there's a small number of values. So if you were to try analyze this as raw data, you would have to set out the 0s and then all the 1s side by side and then all the 2s side by, and you see that you basically went down the paper. It don't make no sense to do that, right? So it's better to represent this raw data in a table. Because the number of different values, 0, 1, 2, 3, 4, is a small number of different values. It means that you can represent each of them in the table. So you do the table and you put the values 0, 1, 2, 3, 4, and you put the frequencies. So these are the values, and you put the frequency of the values down in the second column. All right? And you don't need to group the values. You can list them individually. So therefore, that would be your table. And the data is ungrouped. See it here? The data is ungrouped. You don't group them, you list them individually. And then in this column now, you put in the frequency of each value. So the frequency of the 0 is 2, because there are 2 zeros there. The frequency of the 1 is 5, because there are 5 ones there, and so on. Frequency of the 2 is 8. See, there are 8 2s there, 8 of them, and so on, right? And then we can then analyze the data using from this table. And that is now an ungrouped frequency distribution table. You can understand that so far, guys? And it makes sense. Does it make sense to you?
Yes, sir.
Yes, sir.
Right? Makes sense. All right. So from that now, we can do a sum column. It's a sum column, and we need a sum column to know the total of all the values. Because to calculate the mean, we'd have to calculate the sum of all the values. Now, if you were to list out all the values to calculate the sum, you'd have to go 0 plus 0 plus 1 plus 1 plus 1 plus 1 plus 2 plus 2. You don't want to have to do that. So a quick way to do it is to say, okay, since there are 2 zeros, the sum of the zeros is 0, because 2 times 0 is 0. And since there are 5 ones, the sum of the ones is 5. 5 times 1. And since there are 8 twos, the sum of the twos is 16. The sum of the twos is 16. And since there are 17 threes, the sum of the threes is 51. And since there are 23 fours, the sum of the fours is 92. So this is a nice way to calculate the sum. So sum from a frequency table is always the frequency times the score. And this is how you calculate the total of all the values. So the sum of the zeros is 0. The sum of the ones is 5. The sum of the twos is 16, because there are 8 of them. The sum of the threes is 51, because there are 17 of them. The sum of the fours is 92, because there are 23 fours there. So that's a sum column. And then if you add up all these values now, the sum of the sum column gives you the sum of all the values. So we can do a sum. Well, this is telling us the number of values. The sum of the frequency, you know the number of values. I have 2 zeros, 5 ones, 8 twos, 17 threes, 23 fours. So you add up these, you're getting the number of values in the distribution, which is 55. Then you can have the sum of all the values. That's what this is. Sum of the sum. This is the symbol of a sum of. So the sum of the sum, fx is your sum of each value. Right? Sum of each value. So that tells you that the sum of all the values is 164. So the sum of all the values is 164, and the number of values is 55. And you can divide these two to find the mean. And divide those two to find the mean. All right? The class are good?
Yes, sir.
Remember, fx is your sum column, okay? F times x is just how you calculate the sum. And it's not f of x, it is f times x. This is f. This right here is the frequency times the scores. Frequency times the scores. I'm trying to find the sum of the scores. We'll call it a sum column. All right. So the next thing we want to do now is calculate mean from an ungrouped frequency distribution table. And we just looked at how we can get the sum of all the values and also the number of values. And that's all we really need for the mean. And therefore it comes out to that formula. It's a sum of the sum. It's the sum of the values divided by the number, sum of the f, which is the number of values. Therefore, this is the formula. So it's the sum of the sum. So like you sum the sum column and divide it by the number of values. The number of values right here is the sum of the frequency. Sum of the frequency. All right, let's see there. X is the observed, X represents the observed values, F represents the frequency. Fx is the sum of the observed values, and N is the number of observation, the number of values in the distribution. All right. And so from this table, when we do the sum column, we get this number of values is 55, and the sum of all the values is 164. So you divide them. The mean is the sum of the number of values, which works out to 2.98. So 2.98 is a mean score. It is a 2.98 is a mean of these scores. That's what calculate the mean. So you have to remember this formula. You have to remember this formula up here. All right. That's that. So next now, we're gonna look at median, interquartile range, and semi-interquartile.
So you can explain the formula again, sir.
Huh? This is just the sum of all the values divided by the number of values. So this is a sum column. So you add up all of these, you get the sum of all the values. Just that you don't want to have to add them up. You don't want to have to add them up. Go on, hold on a second. You don't have to add them up by adding up all of these values. When you can add up all of these values, but more time. So the short way to add up all those values is to sum the zeros, sum the ones and get 5, sum the 2s and get 16, sum the 3s and get 51, sum the 4s and get 92, and then you add up all of these to get the 164. That is all really, you know. All right. Let me clear the screen. All right. So that's the sum formula. Sum of all the values divided by the number of values. That's what it is really. So the sum of the number of values is 55, sum of all the values is 164. And this case is divided 164 by 55 and get 2.98. Understand that?
Yes, sir. Yes, sir. Yes, sir.
All right. Then we come now to median, interquartile range, and semi-interquartile. Now remember this thing right here. Relate to the quartiles. Everything is related to the quartiles. Remember what we said the quartiles were? They were the scores that divides a set of data into 4 equal parcels. Middle quartile, and lower quartile and upper quartile. These scores, Q1, Q2, and Q3 are your quartiles. And all right. So what we do when the data is ungrouped is that we can use a formula to locate the position of the quartiles. There's a formula to locate the position of the quartiles. Right? So for the distribution, which is ungrouped, the position of the quartile is as follows. The lower quartile is the 1/4 of the n plus 1 term. I explained that just now. It's a quarter of the n plus 1 term, where n is the number of terms. That tells you where the first quartile is located. The middle quartile, which is also the median, is a half of the n plus 1 term. That's where it is located. half of n plus 1. Then the upper quartile is 3 quartile, three quarters of the n plus 1 term. That's where the upper quartile is positioned. So let me give you some values and explain it. Let me use an example over here. Now let's say we have some raw data. I'm going to relate the raw data back to this. Let's say we have some raw data. 1, 3, 8, 14, 21, 27, 33, 35, 39. What about is that? 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, 9. Let's put in 2 more. Let's put in 2 more just to make it kind of friendly. There are 12 values there now. All right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Oh, that's 11. I need 12. I need 12. Let me shift this over like a bit. Oh man, everything moving. I want to just shift this a little bit to the right. I'm putting another value 0 at the beginning. Put in 0, 1. 12 values. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now we already know how to in fact, let me put in 1 more value, make it 13. Exactly. I'm correct with it. We already know how to divide up this data to get the quartiles. Also we do. Find the median first. And since there are 12 values there, you must have 1 in the middle, 6 and 6. So you have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So you must have 1 in between here. And you have 1, 2, 3, 4, 5, 6. So yes, you have 1 in between there. And the 1 in between there is Q1, which is 21 plus 27 over 2, which then is 24. All right, I'm going to show you that we can find this while using a calculation method. So now this is the bottom half, and this is the top half of the data. So based on that, where would be the first quartile? The first quartile, there are how many values there now? 1, 2, 3, 4, 5, 6. So the first quartile is going to be right here. Right there. Let's change this value to 9 just to make it friendly. Let's change that value to 9. So the first quartile again is the average of these 2 values. Because I like to find the median of these values to get the first quartile now. So I have Q1 here, so this should be Q2. Somebody couldn't tell me that this is Q2. Second quartile median. Now we're doing Q1. So Q1 is 3 plus 9 over 2. So Q1 is actually equal to 6. And in Q3 now, you have 3 values here and 3 values here. So Q3 is between these 2. Q3 is the average of these 2 values. 35 and 39. 35 and 39. So Q3, upper quartile would be, what is that? 37. 37, to be 37. I better give that, that's how you'll find them if you're using a raw data method. But I give it that?
Yes, sir.
All
Yes,
right.
sir.
I'm going to use a formula now and show that we get the same value. I'm going to use this formula now and show that we get the same value to prove that the formula is correct. Three formula them correct. So watch this now. It's not finding the quartiles, you know. The formula is not finding the value of the quartile. It's finding the position of the quartile. That's what these do. You find the position of the quartile. So watch this now. The position, that means position of Q1 is, I can say equal, position is equal to 1/4 of the n plus 1th term. How many terms are there? 12. So it's 12 plus 1. See why should I make it 11? Just to make the values easy. I'm doing this over now, guys. I'm doing this over. I'm going to make it 11 values so that calculation get easy. Osh. No problem. More maths equals better maths. I just want some values that you will understand and appreciate more clearly. So I'm doing
Yes,
this
sir.
over.
Yes, sir.
I'm going to take that out and make it 11 values. As I don't want to illustrate it something that going to bring fractions into. When fractions come into play later, I explain it. So I'm going to use this instead. All right, so ready now. So there are 11 values. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 values. And so one of them is the median. So you're going to have 11 values. You're going to have 5 and 5 and 1 in the middle. 1, 2, 3, 4, 5. And 5 at the top. So this value is Q2. Second quartile. Q2 equals 27. And then you have these 5 values down here. So therefore, this one in the middle is actually a Q1. And then you have 5 values up here. And the one in the middle is 39 is actually your Q3. Q1 is 9. All right. So that's how we find them by just using the position method. Divide it in half, and then the midpoint of the top half is the Q3, and the midpoint of the bottom half down here is Q1, right? That's how we do it by observation. Now, let's say we want to show it now that you can find these positions using the formula, just to prove that these formulae are correct. And remember now, it's not finding the values themselves, it's finding the position of the value. So watch this now. The position of Q1 equals 1/4 of the n plus 1th term. That's what term is, the position of Q1. This is the position of it. 1/4 of the n plus 1th term. The n is 11 and there are 11 values. So this becomes 1/4 of 11 plus 1. It becomes 1/4 of 12. 1/4 of 12 is 3. I mean, that the third value at the third term is your Q1. And if you look at the table right here now, you can see it is the third term, in fact. Is there? First term, second term, third term right here. So it shows you that the third term is actually Q1. And it happens to be 9. The third term is 9. So that says 9 for the third term. But this formula gives you the position of it. Understand that, guys? It doesn't give you the value, to tell you where it is. But understand that?
Yes, sir. Yes, sir.
Yes,
Then
sir.
if you want the position of Q2, the second one, the position of it, right? Let me shift this down. Right? So do we have it? Shift it down. Position of Q1. That. The position of Q2 is now half of the n plus 1 term. So you find the position of Q2, half of the n plus 1 term. So this is telling you where it is in the data. So it becomes half of 11 plus 1 term. 11 plus 1 is 12. Half of 12 is 6. So it's the sixth term you want. The sixth term is the median term. If you count the first 6 terms. The sixth one is the median one. So 1, 2, 3, 4, 5, 6. See? So the sixth term is the median term. And that's what we got here. In fact, so the calculation tells us that the sixth term is the median term, which proves that the formula is correct because it is in fact the median term, the sixth term. And then we'll come to Q3, so I'm going to move this on again. So finding Q3, the position of Q3 is position of Q3 equals 3/4 of the n plus 1 term. 3/4 of n plus 1 term. That is where Q3 is located. So it will be 3/4 into 11 plus 1 term. This is 12. 3/4 of 12 is 9. Because 3/4 times 12. So 4 into this goes 3 times. 3 is 9. So this works out to be 9. I can say the 9th term. Alright, so the 9th term is Q3. So if I count them now on the data, I find the 9th term from the left to right. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9. That's it. That proves that the formulas work. Formula over here work. But that's not. But good.
Yes, 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 sir.
The thing is, we're not using the formula on raw data. We're going to be using them on tables. So the question is, how do we use them on tables? I will still have to be able to find the terms on the tables, That is the thing. We still have to be able to find the terms on the tables. So let's continue now. So that little exercise was just to prove that the formula works. All right, formula work. All right. So we're saying now a cumulative frequency table is required to find these terms. Why do we need a cumulative frequency table? Find the terms. Now, what's a cumulative frequency table? A cumulative frequency table is one that it counts how many terms you have as you go from data to data. That's what it does. So like you're counting the values. So it's a way of counting the values. So because on this table, we were able to count the values by just looking on the right side of the screen I'm talking over here. I was able to count the value by just looking. 1, 2, 3, 4, 5, 6, and so on. In a frequency distribution table now, you count the values using a cumulative frequency table, a cumulative frequency column. Cumulative frequency. Cumulative means adding up or counting up. And you're doing it with the frequency. That's why it's called a cumulative frequency. So you see, this table shows, cumulative frequency table, it shows how many terms are less than or equal to any value. So you're basically counting the terms as you go. Right? It shows how many terms are less than any given value. So you're counting up the terms as you go. All the group data, we're going to be using this cumulative frequency column and tables a lot more. But for now, this is it. So in this example over here, those are the scores. The data is ungrouped, and I want to find the quartiles. So what it is, I need to be able to count up the values as I go from group to group or from value to value. So when I finish, for example, I know that when I'm here, I have only 2 values. But when I reach the ones and finish the ones, I now have a total of 5 values. So, and then when I finish with the 2s, I know a total of, no, not 5 values. I know a total of 7 values because I have 2 here. And when I finish with, I put in 5 more. And when I finish with this, I put in 8 more. So let me show you the cumulative column now. That is, so we're counting how many values we have less than or equal to the score here. How many values are less than or equal to this score? You don't really need this column still, you know. This is not an absolute necessity if you know what you're doing, right? But we are counting how many values are less than or equal to 0. 2 of them. How many values are less than or equal to 1? All the values less than or equal to 1, and those 2, 7 of them less than or equal to 1. How many values less than or equal to 2? These are the values that are less than or equal to 2. How many values? These are the number of values less than or equal to 2. You're going to need that cumulative frequency column there. That is it. So when you finish putting in, you can check it now. When you finish putting the 2s, the 0s, I mean, you have 2 values. Then when you finish putting in the 1s, you have 5 of them, you know a total of 7 values. When you finish putting in the 2s, there are 8 2s you put in, you have a total value now of 9, a total of 9 values in the distribution. When you finish putting in the 3s, in which there are 17 3s, you know of a total of 32 values. And when you finish putting in the 4s, which are 23 of them, it means that you have all the values now, which is 52, 55. 1 second. Hello? Hello? Yeah? Yes?
What's your name? Kapura?
Yeah. All right, guys, sorry about that. Right. So the cumulative frequency column over here, right? It allows you to know how many values you have as you go from value to value in the table. That's what it does. And you need to know how many values you have because remember, we want to be able to find the position of values. We want to know which value is in a position, I should say. We want to know which value is in a particular, in any position, in a particular position for the quartile. So let's continue. Maybe when I'm done, you'll understand it. I explain it over if I need to. So now we know that there are 55 values. And now we want to find the position of Q1, position of the first quartile. So this is calculation for the position of the first quartile. For the n, remember it's quarter of n plus 1. All right, so the position of the first quartile is the 14th term. So somebody look at the table now. Look at the table up here and tell me which group would have the which line would have the 14th term in it. Somebody look at the table and tell me which line would have the 14th term. Look, when I finish this line, I have 2 terms. When I finish this line, I have 7 terms. When I finish this line, I have a total of 15 terms. When I finish this line, I have a total of 32 terms. When I finish with this line, I have a total of 55 terms.
Third line, sir.
The third line, beautiful. Because when you finish here, you'll have 7 terms. So this line consists of the 8th all the way up to the 15th term. But understand that line right here that I'm marking. It has the 8th to the 15th term. Because when you finish up here, you were just at the 7th term when you finish with that group. So the 14th term is, as Antoine said, one of the ones inside here. So it means that what is the 14th term? 14th term is our. What's the value of the 14th term? Remember, these are the values over here, guys.
There are 2.
Are 2. These are the values. The 14th term is a 2. So the 2s are from the 8th term up to the 15th term. So the 14th term is a 2. So we know the 14th term is a 2. And the 14th term is one of these. All right, let's continue. The position of Q2 is half of the n plus 1 term. half of n plus 1 is the 28th term. So the 28th term is your Q2. So you need to find the 28th term. So which line would the 28th term be in? Which line would the 28th term be in?
Sir, the fourth line, sir.
Fourth line. Because this line stops at the 15th term, and this line stops at the 32nd term. So it has the term the 16th up to the 32nd term. So the 28th term must be one of these. Must be one of those. So the 28th term is a what? 28th term
A
is a
tree,
what?
sir, a tree.
Tree. So it means that the median is 3. And the 28th term is a 3. Then now we want the upper quartile, which is 3/4 of the n plus 1 term. That's a formula. 3/4 of the n plus 1 term. And this is telling us that the upper quartile is the 42nd term. So which group would have the 42nd term? Or which line would have the 42nd term in it?
Sir, the last line, sir.
Good, because this one finishes at the 32nd term. This one goes from the 33rd to the 55th term. So if you want a 42, it's in this group. Right? So basically then, and then therefore what is the 42nd term is our
It's a 4, sir.
42nd term is a 4. And the 42nd term is in here and it is a 4. In this kind of that's it. So see here now, 14th term is in there. The 28th term is one of those. See that on the table, you know. And the 42nd term is one of those. And then those are the terms over on the right side, on the left side. So the 14th term is Q1 is 2. The 28th term is 3. Is a 3. And the 42nd term is a 4. So now you know your quartiles. Q1 is 2, Q2 is 3, Q3 is 4. And therefore, since you know your quartiles, you put them down. You can now calculate, well, identify the middle one as the median. And then calculate interquartile range, which is Q3 minus Q1, is 4 minus 2, which is 2. The semi-interquartile range is half of that, is 1. Obviously, guys, you understand that? You understand
Yes,
it?
yes,
Yes,
sir.
sir.
Yeah, but here's the thing about this topic now. They don't really set ungrouped data a lot in CSEC, you know. You must set group data. All right. You must set group data. So, and then when you set group data, you want to find a quartiles, you have to draw a cumulative frequency curve. You don't calculate it when the data is grouped up. The way you do the things is different. Say over here, when the data was raw over here, we find the quartiles by just how they are positioned by observation, really, on the right side of the screen. When the data is ungrouped, you calculate the quartiles by using the formula for position of the quartile, which are these that I'm putting in block. And then you go on the table and find which value match that position, which value is in that position. And that's how we get the quartile. When we're doing group data, we're gonna have to find the quartiles from a cumulative frequency curve. So the method is gonna be different still. So it's 3 different ways of finding quartiles depending on the data that you have. The data is grouped, ungrouped, or raw data. All right, so let's continue. So the next thing we have to do now are statistical diagrams for ungrouped data. Statistical diagrams. So we did statistical diagrams for group data for raw data that I did. So we did line graph, we did pie chart, or we did bar chart. Now when the data is ungrouped, we can do a histogram. Now, a histogram is a bar chart, just that the bars they kiss each other. The bars are joined side by side, and they are joined at a value that we call the boundary values. They are joined at the boundary values. And histogram, why bar chart are used mainly for discrete data. Histograms are used mainly for continuous data. Because what happens is that the data continues from one group or from one set, from one data value to the next. When we start with the group data, it will be more glaring to explain why the data we can use a histogram. Remember, continuous data is mostly for measurement. Continuous data is measurement data. And measurement data, you tend to put on a tend to draw a histogram. But discrete data, which is counting data, you tend to represent those with a bar chart, because you know you're counting specific values, right? Continuous data is measurement, so the value that you use depends on the accuracy that you want from the data, right? In terms of the measurement, how accurate do you want the measurement to be? 1 decimal place, 2 decimal places, or 3 decimal places. All right. So this consists of vertical rectangular bars which are joined side by side. Remember, the bars of the histogram kiss each other at the boundary values. The bars of the histogram kiss each other at the boundary values. They are joined side by side at the boundary values. So you can make a note. Joined side by side at the boundary values. I'll explain what boundary values are later. All right. It says now, when the width of the bars of the histogram are equal, the height represents the frequency. So at CSEC level, they tend to make the width of the bars of the histogram same. So in other words, they make them the same thickness. And so you draw them to the height of the frequency. You then draw the bars to the height of the frequency on the graph. All right. So you can do an example with this data. So for that data, we're going to do a histogram. So because the data is ungrouped, these values are going to be in the middle of the bars of the histogram. In the middle of the bars of the histogram. They're going to be in the middle of the bars of the histogram. And what we're basically saying is that this value, 1, can take values that are less than 1.5. And take values that are less than 1.5. Anything that's less than 1.5 is approximately 1. But greater than or equal to 0.5. Students understand that? Any value, let's say you're measuring something. And when you measure it, you put on 1. I measure it to the nearest one number, you put on 1. It's not stretching, I don't know why it's stretching. All right, good. I can write on it again. Okay. So if you're measuring something and it measures 0.5, 0.5 is approximately 1, don't it? Don't it? Students? 0.5.
Yes, sir.
0.5 is approximately 1. But what is 1.4 approximately? 1.4 is approximate to?
1.5?
No, to the nearest whole number.
Sir, 1.
1.
1. 1.5 approximate to?
2.
That's why right here I have less than 1.5. So any value that is less than 1.5 is approximately 1. You understand that? So what it means is that any value that is 0.5 equal to or greater than 0.5 but less than 1.5 will automatically become equal to 1, or it's rounded off to 1. And that's why that first value can take any measurement that is greater than or equal to 0.5 but less than 1.5. That 0.5 and the 1.5 are called the boundary values. Because the value 1 can be used for any value that is greater than or equal to 0.5 or less than 1.5. The second group would be greater than or equal to 1.5. So that's it right, 1.5 is approximately 2. So greater or equal to 1.5, but less than 2.5. So the value 2 can be used for any value that is greater than or equal to 1.5, but less than 1.5. You understand the second value that I wrote in there, students?
Yes, sir.
Understand them?
Yes, sir.
Is that a yes? I don't hear the first word.
Yes, sir.
Yes, sir.
And the third one is greater than or equal to 2.5 can go inside here, but it has to be less than 3.5 to be considered 3. Agreed?
Yes, sir.
The next one is greater than or equal to 3.5. Any value that is greater than or equal to 3.5 can be approximated to 4, but it has to be less than 4.5. Once you reach 4.5, you're going to call it 5. And then any value that is greater than or equal to 4.5 can be used in this group, but has to be less than 5.5. Those 0.5s and 1.5s are called the boundary values. They are called the boundary values. So the boundary values of 1 are 0.5 and 1.5. The boundary values of 2 are 1.5 and 2.5. The boundary values of 3 are 2.5 and 3.5. The boundary values of 4 are 3.5 and 4.5. The boundary values of 5 are 4.5 and 5.5. So those things in red are the boundary values, and that's where the bars of the histogram must draw. Now, to show you why they are the boundary values and why the bars must join side by side, is because where this first value ends is where this second set groupings begins. See, they are the same value. Same thing for the second set. Where this group ends, or where that value ends, this one begins across here. And similarly, where this 3.5 ends, the other one begins there. Where this 4.5 ends in that group, the 4.5 is there. So they have the same value. So where one data ends, the other one starts the same place. Just that in one case, you have in the less than, and the other case, and the next one you have in the equal. That's why we say you join the bars side by side, because where one value ends, the other one begins, and so on. So you have to draw the bars side by side. And you draw the bars from 0.5 to 1.5, 1.5 to 2.5, 2.5 to 3.5, 3.5 to 4.5, 4.5 to 5.5. That's where you draw the bars. So the bars join each other at the boundary values. And then the 1, the 2, the 3, and the 4, and the 5 are going to be in the middle of the bar. So let's look at it now. Let's look at it. So this is my histogram I'm going to draw now. That's my histogram. That will be my histogram. Let's look at the details of the histogram. Now you can see that the bars are joined side by side. They are joined at the boundary values. So if I were to zoom it up, let's zoom it up and look at it. Let's zoom it up and look at it. So this value right here is a red ink. The bar right here is 0.5. And right here would be 1.5. And right here would be 2.5. Right here with 3.5. Right here with 4.5. And you can see the bars join each other at the boundary values. And then the 1, 2, 3, 4, and 5, they are in the middle of the bar. So the 1 is in the middle of the bar, the 2 is in the middle of the bar, the 3 is in the middle of the bar, the 4 is in the middle of the bar, 5 is in the middle of the bar. But you can see that? So the
Yes, sir.
bars join each other at the boundary value. You have to remember that, guys. You must never have any space between the bars and a histogram. And then now the height of the bars now match. The height of the bars match the frequency that they're representing. Right? So the first bar go to a height of 2. See there? 2. The second bar goes to a height of 5. See there? 5. The next bar goes to a height of 23. 23 here. 23 up here. So the next bar drops down to 17 here. So the next bar drops down to 8. It's 8 here. So all right. So this guy, that's a histogram. Just need to practice it. But remember, guys, the bars of the histogram are joined side by side at the boundary values. At the boundary values. We'll start practicing. We'll show you how to draw them and get them easily. And then sometimes some people doing them and they just put on the boundary values on the graph and draw the bars right at the boundary values. And then in the middle of the bars is where you have the scores. The 1, the 2, the 3, the 4, and the 5. All right? And that's where you draw the histogram. That's how we draw a histogram. When we do group data, we're going to do a similar thing to draw the histogram. We're going to do grouped data. All right? We're going to do a similar thing. Let's continue. The next diagram we can draw is a frequency polygon. Frequency polygon. Now, frequency polygon is basically just like a line graph, but because it's a polygon, you have to close the 2 ends down to 0. You have to bring the 2 ends down to a frequency of 0. You have to bring the 2 ends down to a frequency value of 0. All right, I'm going to show you how you bring the 2 ends down to a frequency value of 0. But it's a frequency polygon, so because a polygon is a closed shape. So you cannot just draw a line graph. So you start out like a line graph, but then you have to close the 2 ends to make it into a polygon. And again, it is mainly used for continuous measurement data. All right. This is a line graph obtained by plotting observations versus frequency. It says the points correspond to the midpoint at the top of the bars of the histogram. So the histogram that we just draw a while ago, we can actually draw a frequency polygon by joining the top of the bars with straight lines, because the top of the bars would be the points in the table. So we have this table. So I'm saying we're going to draw a frequency polygon. So if you start out with histogram, what you will find is that, look at it now. This point at the top of this bar here is like the coordinates of this point, 1, 2. This top of the bar is this one. It's like the coordinates of these values, 2, 5. Top of the bar of this third bar in histogram. Top of third bar in histogram is these values, 3, 23. Fourth one is 4, 12. And the last one is 5, 8. And basically plotting these points on the table, on the graph right here. Right, so I'm getting all these points. I'm just showing you, I'm just leaving the histogram there from the previous slide to show you that the points correspond to the top of the bars of the histogram. They correspond to the top of the bars in the histogram. All right? That's what I want to show you first. If you just draw the frequency polygon by itself, just plot the points and draw the line graph first. All right, so we're going to draw the line graph. So that's a line graph first. So I join those points. But then because of polygon, you have to close it. You have to close the two ends. So how do you close it? How do you know where to close it? You close it by going, pay attention now. You close it by saying, okay, the value before is based on these values down here, going up. The value before 1 would have been 0. And 0 had a frequency of 0 because there was no 0 on the table. There was no 0 score on the table. Let me erase and show you about the table. Right, the table did not show any 0 score, so the frequency of 0 is 0. Then to close the other end, you want a value after the 5. So the value after 5 would be 6. And the frequency of 6 is 0 because they did not show 6 on the table. So I have to close the other end right over here at the 6. And over here at the 0. And so you close the two ends of the polygon that way. All right, so if I move the histogram, you see the line graph there. I see the line graph, but then I have to close the two ends as I said. All right. So those are the 2 points that I have to close the two ends. These 2 points that I put in, one before the first point and one after the last point, but they have frequencies of 0 because they were not on the table. So if I put a value of 0 on the table, the frequency of 0. If I put a value of 6 on the table, the frequency is 0 because they were not given originally. So those 2 points are represented by this point and this point. Right? And that is how you close your polygon, by putting in those points. And then once you put them in, you join the ends. You join the first one there, you close it, you close the polygon at that end. And then you do the next end as well, and close the polygon over there. And then that's the frequency polygon. Understand that? This thing just need practice and practice. I'm trying to make it.
Yes, sir.
Right. So that's how we draw a frequency polygon. So you draw a line graph for the points first. You must close it down on the x-axis. So if they don't give you values to close it, you have to insert the value that will come before the first value, which in this case is 0, and the value that will come after the last value, which in this case is 6. And make those have a frequency of 0 since they were not given in the data. Those values, I put them into a value of 0. And that's how you close the frequency polygon. All right, that is that. Statistics of group data, that's ungrouped data now, guys. I'm gonna start the group data information, I think maybe on Sunday. We might just practice some questions, but I don't want to go too far into the group data today, but I want to start it and give you some stuff that is relevant for group data. I want to watch about the video later and look back at the things that I've said about ungrouped data. That's basically just it a while ago. You know? That is it. That's what they're asking for ungrouped data. Asking for mean, which is the sum of the values. So you need a sum column divided by the number of values. That's to get the mean. Then they can answer for median. I show you find the median, which is half of the n plus 1 term, and you need a cumulative frequency column to do that when the data is ungrouped. The data is ungrouped. And the portion of the quartiles is 1/4 of the n plus 1 term, Q1, 3/4 of the n plus 1 term, or Q3. And then interquartile range is Q3 minus Q1. Use a cumulative frequency column on the table to find the position of the scores, position of the values, and then find the values in the original first column. That's what we just did. We looked at the diagrams that you draw from ungrouped data, and we did a histogram first. So the important thing with a histogram is that the bars go from boundary value to boundary value, and I show how you can know the boundary value. For example, the boundary value I can write the boundary value for any value. So if I put on 10, the boundary values of 10 in statistics is less than 10.5, but greater than or equal to 9.5. Because anything 9.5, 9.6, 9.7, 9.8, 9.9, all of those values would approximate to 10. All right? And then on the other end, if something is 10.5, 10.5 is approximately 11. That is why we have the less than sign right there. You can have a value that is equal to 10.5, being 10, but 10.5 will approximate to 11. So you need your values to be less than 10.5. Basically, these are the boundary values of 10. Those are the boundary values of 10. 9.5 and 10.5. This one is called the lower boundary value. This one is called the upper boundary value. So every value that you see in statistics have an upper and a lower boundary value. These are the values that can be taken to be equal to 10. Anything 9.5 or more, and anything less than 10.5 can be taken as 10. And we run it off to 10 in statistics, especially for measurement data. Measurement data. But understand that?
Yes, sir.
All right. Then now come to, I remember the bars of histogram go from boundary value to boundary value. And we said the middle of the bars correspond to the values in the data. And then the height of the bars is your frequency. I spoke about a frequency polygon. A frequency polygon, two ends must be closed down to the x-axis, down to 0. Because it's a polygon that you're drawing. A polygon is a closed shape with a number of sides. You have to close it. You can't leave it on, you can't leave it open. Close the two ends. So what you do, you plot the points first. Remember, I always put frequency on the y-axis. You plot the points first. Score against frequency. You plot them like you're plotting points. And you draw a straight line between the points. You like you draw a line graph first. And then to convert it into a polygon, you have to close the two ends. So the left end, where the values are smaller, you look for the value that would have come before the first value in the table. And you give that a frequency of 0. And then on the other end, you look for the value that will come after the last value in the table, and you give that a frequency of 0. That's what you do. All right? So I'm just repeating what we did earlier. You need to watch about the video under the video. But let us start the introduction to group data, statistical group data, where the methods again are different. The methods are different. And one of the first things I want to point out to you is that when the data is grouped, you are mainly estimating. Everything you do is really estimating when the data is grouped. And when the data is grouped, why you have to estimate is that because you don't know the actual values. You don't know the actual values in the sample of the data. Or the data is grouped, you don't know the actual values. And so you're only estimating. All right. Everything you do for group data is primarily to estimate stuff. But I'll show you, and I'll explain it more as we do it. All right. So first thing, when do we have the need for group data? We have the need for group data. We have a large number of different values so that you can list them in a table, one. Basically, that's it. A large number of different values, but also when you have a large frequency of the values. All right? So that's what this is saying. When the data analyzed becomes plentiful and has a large range of values. You have a large range of values, large number of different values. It may be convenient to arrange the data into groups. They put the data in groups or you call them classes. And then we put them into groups. We prepare what we call a group frequency distribution table. And the statistics is different for group frequency. So the way you do things now will be different again. The way you find mean is gonna be different. The way you find median is gonna be different. The way you find mode, the way you find everything, median, interquartile range, the way you do it is gonna be different because now the data is grouped, and also because you are now estimating. Almost everything you do now, you'll have to estimate. All right, so that's when you have the need for group data. All right, let's look at an example. So that's an example right there. So you're looking at the mass of, say, mass of the number of students, right? So this is a data showing the mass of a number of students. How many students? 37 students. That's a lot. And these are the masses. Mass can range from 35 to 54. And there are 37 students. Now suppose you were to list the mass of the students. You have a table, you don't need a table, we'll go like this. You have write the mass, and you write the frequency. And if you did not group the data, you'd write 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45. Jeez, I'm going to get long already. 46, 47, and go all the way down to 54. So the last part is 54 on the table, all the way down to 54. What would happen there? That would make sense, guys. The table will be too long, too much. But understand that. If you were to list the scores individually like that, it will be too long. The table will be too long. Because you have too many different values in the data. And that is why instead of doing it that way and listing them, you put them in groups. So you make a group of 35 to 39. And they make a group of 40 to 44. They make a group of 45 to 49. And you make a group of 50 to 54. And so you only have now 1, 2, 3, 4 set of data, 4 lines instead of all these lines. Understand, my students? Understand, my students?
Yes, sir.
Yes, sir.
Right. That is why you have to group them. But then now you have a drawback. You have like a disadvantage now when you group them. Anybody think I can tell me the disadvantages that I have now when they group them based on this table? Because if anybody can see the disadvantages that we have when you group the data like that. So you group the data and say, all right, 35 to 39 kilograms. All the students will measure 35 to 39 kilograms in this group, and there are 12 of them. 12 students.
It's not as accurate, sir.
Huh?
Sir, it's not as accurate.
In what sense? Tell me. Be more specific.
Right, sir, because you say like 35 to 39, sir, and it's a turbo them, sir, so you don't really know the weight of anybody, really.
Jesus, change, boy, you're brilliant. He's who said that a while ago. Let me hear. Let me see. He's who talk.
Josh, sir.
Eh? He's who talk. Who talk? Talk again.
Josh, sir, Josh.
That is exactly the reason. And if them asking a CSEC, that you will tell them. I just said a while ago. And everybody else. You don't know the actual measurement of the 12 people. That is the drawback with this. They tell you it's between 35 and 39 and tell us you have 12 persons. But you don't know where the 12 people they measure actually. You don't know. You don't know how many of them measure 35. You don't know how many of them measure 34.8. Come on, 34.8 can work this way now. You don't know how many of them measure 39. You don't know how many of them measure 38.5. You don't know the actual measurement of the people. And the same thing for all the groups. The 8 persons in this group, you don't know the actual measurement. You don't know. That is one of the drawbacks with group data. And therefore, we have to estimate stuff. We have to make some assumptions. And one of the assumptions that will be made is that we are going to calculate what we call the midpoint of the group. We're going to look at it soon. We want to calculate the midpoint value of the group. The midpoint between 35 and 39 is 35 plus 39 divided by 2 to get the middle value. That's 37. And what you end up doing is assuming 37 is the midpoint value. You end up assuming that all 12 persons measure 37. That's an assumption that you'll have to make, for example, when you're calculating the mean. So you use the midpoint value, which is 37, to represent all the students in the group, and maybe none of them measure 37 in fact. Chances are none of them know we're 37, you know. But you're gonna have to be using 37, which is the midpoint value of the group, or you can call it the average value of the group, right? To do your calculations. And that is why we'll be estimating. And here's the wicked thing about it now. CXC will ask you that very question. So for example, when you calculate the mean from group data, and it's an estimated mean, CXC will ask you the question, why is this an estimated mean? The same answer that Josh just gave is the answer. You don't know the actual measurement of the students because the data is grouped. You don't know who measure what because the data is grouped, and that is one of the deficiencies with group data. And that's why everything we do in statistics of group data is estimations. I always say to the students, the statistics of group data is estimation statistics. Estimation statistics. When you can get accurate answers for raw data and can get accurate answers for ungrouped data, okay, you know the actual number of scores in the ungrouped data when the data not grouped. For group data, because you don't know the actual measurement of the things. I don't know the actual count of the things because the data is grouped. Then you really know how to be estimating stuff. And almost everything you do when the data is grouped is estimate. So when you're doing a question in statistics, really, you know, and then give you a data group, you know, most of the questions will say estimate this, estimate that, estimate this, and even some of the diagrams that you draw. So we're gonna have to draw a cumulative frequency curve to calculate the median, find the median, and to find the interquartile range and the semi-interquartile range, to find the quartiles. We're gonna have to draw a cumulative frequency curve. We can't do it like how we do it and say half of the n plus one term and find it that way. So you draw a cumulative frequency curve, right? And then you use a cumulative frequency curve to try and find the quartile because you're estimating. And then you find other things as well from a cumulative frequency curve, but you're estimating. Understand? So that's the first thing I wanted to point out, and I'm very happy that somebody gave that answer. But that is exactly what is happening. All right, that is it in a nutshell right there. What is happening when the data is good? You don't know the actual measurements. All right. So the number of students in this would be 37. That's another example. Number of students is 37. I think we might use the same thing to do some stuff. But I think we're getting into now some of the terminologies that we have to know and understand. I think that's what I'm going to end the class today. Some of the terminologies that you have to know when the data is grouped. And before we go on, there's another thing I want to show you before we go on. All right, the group data. And this is it. The group also has boundaries. The groups have boundaries. So the first group can take values from 34.5 up to less than 39.5. What I find in recent times, CXC has started to give the table with values written like this, with the less than equal to and the less than. They have started to do that more frequently these days. Because you see, instead of writing 35 to 39, then you can write this. Then you can write this instead. You put it down here. Then you can write x. We call the value x less than 39.5, greater than or equal to 34.5. That does simply still mean 35 to 39, you know. CSEC has started to sort of write it like this instead in recent times. So they give the boundary values instead, right? The 35 and the 39, they are called limit values. They are the limits, are the class limits. The 34.5 and the 39.5, they are the class boundaries. They are the boundaries of the class. They're like the extremes of the class. And when you're gonna draw a histogram for this kind of data, you're gonna draw the bars from these boundary values to these boundary values. That's where you're gonna draw your bars. From boundary value to boundary value. That's where you're gonna draw the bars. Because they represent the width of the class, the width of the group. The group, they're also called classes. This thing is the first group or the first class. The first class interval or the first group. The first group or they call it the first class. It's a class or it's a class interval. All right. So I just want us to appreciate that for now. But let's just look now at some of the definitions that we have to understand and see test your knowledge on these things all the time. These words and these definitions and these phrases and these terms relating to grouped data in particular, you have to know them, understand them to the T. See them here now. The first one is what we call a class interval, or you might just simply call it a group. Class interval or group. A group. So a class interval, see here, a class interval is a group of data. And in this one, there are 1, 2, 3, 4 groups. See, there are 4 groups. 1, 2, 3, 4. 1, 2, 3, 4. So like you can call it class interval 1, class interval 2, class interval 3, class interval 4. I might say the first class interval, the second class interval, the third class interval, the fourth class interval. All right? And sometimes instead of saying class interval, they just call it class. First class, second class, third class, fourth class. And sometimes they use the word interval. That's the same. And sometimes they use the word group. The word group. All right? So the third class interval is 45 to 49. And note, I put the unit on it, kilograms, because this is the third one. This is the third one. And I said kilogram because the data is in kilograms. Very important. So I put the kilograms there. But understand that? So move on. Everything important. Understand that, guys?
Yes.
Third class. Good. Then we have the class limits. Class limits are the endpoint values as they appear in the table, the limit values. So the 35 and the 39, for example, these are the limit values. There's a lower limit and an upper limit. So the values as they appear in the table are called the class limits, the limit values. These are the end values of the class interval as they appear in the table. The lower limit of the first class is 35 kilograms. See here? The lower limit is this one, the one on the left, is 35. That's the lower value as it appears in the table. Class limit. The upper limit of the third class, this is the third class. Third. Upper limit is 49 kilograms. See there? Kilograms because that is the unit. 49 kilograms. But I go to that, those are the class limits. But I go to that. The limits are the end values as they appear in the table. You have a lower class limit and an upper class limit. Then we come to class boundaries. So class boundaries are the values between which the values of a class can be taken. So these are like the end values of the bound of the class. the same 0.5 business and the 0.5 business. I can take values from 34.5 up to less than 39.5. Those becomes the boundaries. And when you draw your histogram, these values correspond to the boundaries of the histogram that you draw as well. You draw the boundaries of the bars and the histogram at these values as well. And that's it. These are values between which values for a class can be taken. So the values for the second class can be taken here. See here? For the second class. Values for the second class can be taken from here to here. See, this is the second class. So I can take a lower, this was a second class of 39.5 and up to 44.5. But you see, it's always less than the upper one. Because if you make it equal to the upper one, it can become 45. And the limit up here is 44. Can go past 45. All right, that's why it is written like that. So these are the two boundary values. Two boundary values for this class right here. That class. All right, better go to that.
Yes, sir.
Yes, sir.
All right, those are the boundaries, right? The lower class boundary of the second class is 39.5 kilograms, note that I put kilograms. And the upper class boundary for the second class is 44.5 kilograms. Those are your class boundaries. All right, let's continue. Take my time in this section because I ask questions and these all the time. Right? I'm going to end the class with this today, get an early day to come and watch what I've told you. Next thing is the class width, or there's sometimes a class, they call it class size. The width of the class interval or the class size. How wide is the class? But a common mistake is a person's to do, for example, this class to do 39 minus 35. Wrong. The width of the class is how wide the data that can go in that class. Remember, this class can take values from 34.5 all the way up to 39.5, all the way up to less than 39.5. So the width of the class is how wide this is. How wide that is. Not the 35 to the 39, but the 35 to the 39 is just 4. But the class width actually is 5, because I work out 5, subtract them. And I can also know the class width is 5, is that these lower limit values, they're going up by 5, you see? They're going up by 5. And these upper limit values are also going up by 5. And the data usually is symmetrical, you know. When they give you the data normally in CSEC, the data tend to be symmetrical. But it's going up by 5 as well. Yeah.
So you can use that way to find it out always, or you have to subtract sometimes.
You want to subtract, you must always do the subtraction if they ask you for it. But this is a good way to have an indication of what it is. That the class will be fine. Because the data tend to be symmetrical all across and down. They go down by 5, they go across by 5. So they go down from group to group by 5, but also the width is also 5. So everything tends to be symmetrical. All right, the width is also 5. So it will be the upper boundary minus the lower boundary. Remember, guys, class width is equal to the upper boundary minus the lower boundary. And for CSEC, they tend to give questions where the class width is the same for all the classes in the table or in the data. So all of them have the same class width. But generally speaking, it is the upper boundary of a class minus the lower boundary of a class. I want to know how wide the data is that can fit into that class. There's always the upper boundary minus the lower boundary for the class. See there? Not upper limit minus lower limit. We use upper limit minus lower limit, meaning like, for example, 39 minus 35. Right? Like, for example, 39 minus 35, that is going to be wrong. Use those two. You must use the boundary values. The width of the first class is 39.5 minus 34.5, which comes out to be 5, the same 5 kilograms. And as I said, the lower limits are going up by 5 and the upper limits are going up by 5. Because the data usually is very balanced and symmetrical. So when you draw the histogram bar now for this, the width of the bar must also be 5. The width of the bar must also be 5. All classes tend to have the same class with the discussion they do, because everything increasing by 5. Class midpoint. Class midpoint is the value that is at the halfway mark of the class. The value in the middle of the group, as it says, midpoint. So usually it is the average of the two boundary values by definition, but also can be found using the average of the two limit values. But by definition, it is the average of the two boundary values because you want to find the value that's right in the middle of the class. Because when you're doing some of the statistics, you're going to have to use that value to represent the entire class in your calculation. Right? Because remember, the data is grouped and don't know the actual score done by the values in the group. So when you want to find a value in the group to use, you use the midpoint value. The class midpoint is a single value in a class which can be used to represent the entire class. It's defined as the average of a class boundaries, but can be calculated using the average of a class limits. It can calculate using the class limit. So you add these 25 by 3 to find the middle value. Right? So, and another thing now, when you find the midpoint values, they also be going up by 5. So that if I put in midpoint values on this table, the one is 37, next one is 42, next one is 47, and next one is 52. See, they're all going up by 5 as well. So everything going up by 5. The lower limit going up by 5, upper limit going up by 5. So the midpoint also will go up by 5. So we calculate the first one. I don't have to calculate the rest. I just keep adding 5. Because I realize that these values are going up by 5. The midpoint also will go by 5. Those are the midpoint values, guys. Those are the midpoint values. So these are the things that I want you all. I'm not going to get into the statistics yet. I estimating the mean. I'll do this in the next class. Right? But I want you to get familiar with the terminologies that I gave today for the group data. Right? So I want you to watch over the video. All right? Get the understanding of these things good, so that when we start to get into the questions, the application is a lot easier. We understand what is happening behind the scenes with this thing. All right, so I'm gonna stop it there for today and give you a chance to go and look over the video and stuff. Let me look and see if there are any questions I might want you to do as yet. Let me see. Today is just information I gave you. I want to practice and stuff before getting to any questions. And so let me see if there's anything I want you to do. Where is it again? Where is it? Where is it? Let me see. Homework. All right, so let me see if there's any question that I would want you to maybe attempt. So you see, most of the questions here is grouped, see? Group. This one is grouped as well. Most of the questions is grouped. Hard to find ungrouped, see? Group. So I'm not ready for you to do it yet. This one is also grouped. All examples are grouped, so that's what I told you. They hardly ever set ungroup data. I think they set one on a paper recently, but I find it and let us do it. Let's set the ungroup. I wonder if I can find it. Let me see. Let me see if I can just take a quick look and see if I can find it. It's one of those recent papers. Let's set the ungrouped data question and let me see. Let me see quick. 2019. One of the most recent papers. I think it's past 2019. I mean, like very, very recent. Statistics come on every paper, eh, guys. I can't recall a paper that don't have statistics on it, so brace yourself. That is a topic still, not to worry. It's on every paper. 19. One of the more recent papers, they give a question that was ungrouped. As most times the data is grouped. See, this one is a grouped one, so that's not it. A recent paper, man. Let's see. January 2019. January. Let's try. Let's try January 2021 and see. If it was January 2021 or some other choice, I went into. Okay. Just paper one that looking at the one, the paper twos. Let's see if it's this one, 2021. Let's see. They set the ungroup one recent. They don't set them a lot. Aha. See? Ungrouped. Told you. See that? Says 60 students took an algebra test, which comprised of 50 multiple choice questions. It said the number of correct answers that each student obtained is recorded in the table below. All right, so the number of correct answers is the number of correct answers here. And these are the number of students, right? So this is supposed to add up, let's say 60 students. This is supposed to add up to 60 right here. So let's check it out. Let's see if we can run through this question as a one example. They don't set a lot of these. Right? They don't set a lot of these. Let's see. We have to calculate on this. Can run through this one. We can fast maneuver our way through this one. Let's see what we can do. Mathematics, more maths equals better maths, right? Let's make sure. So this is supposed to add up to 60. Right? The number of students, gotta say we're 60 students. 50 multiple choice questions. So the lowest anybody got was 8. And the highest anybody got was 15. So nobody got less than 8. All right, so let's just check if this add up to 50 to 60. All right, let's just check it. 6 plus 14, that's 20. All right, so this is just 10 more right here. 10 plus 10. Yeah, and this is no 20 more. And 30 more, right? So it's correct. Add up to 30. All right. So it says use the table. So let me come off camera. I think I'm on camera still. Let me come off camera. And go back to the first. Get a one example in for the days out. More maths equals better maths every time. All right, let's go. We don't set a lot of ungrouped data questions, guys. Believe me. Get one, do it. Let's see what it says now. It says use a table to determine the number of students who had exactly 13 correct. Exactly 13 correct. Easy question, right? Easy. Exactly 13. What the answer for this one, guys? How many students had exactly 13 correct? Somebody tell me from the table there. How many students had exactly 13 correct?
11, sir. 11, sir.
Right here. So 13 there. 11 students. Beautiful. 11 students. 11. The modal number of students. Modal number of correct answers. The modal number of correct answers. Talk to me. What's the modal number of correct answers?
Sir, 9, sir.
Beautiful. Remember, this is the frequency now. So over here, these are the scores. These are the frequency. The mode is not a frequency. It is the score that corresponds to the highest frequency. The highest frequency is 14. So this guy right here is your mode. Beautiful. The 9 occurred most. Most people get 9. 14 persons get 9. So the mode is 9. 9 is the number of answers, correct? More than number of answers. The median, all right. See here now, this is a question for you now. The median number of questions correct. Talk to me now. The median number of questions correct. We're gonna work that out now. Somebody tell me. The median. The data
Sir,
is
arrange the number of students in order, sir.
the number of students in order.
No, it's the correct answers.
No. Background bad. Come again. To find the median number of students, what do we do? And the data is
So wouldn't you just find
10 and 12 and divide it by 2?
say that again?
Add 11 and 12 divided by 2.
Which 11 and 12? These two?
so yes, sir, no the square shot
Yes,
of
yes,
So
sir.
why are you gonna use 11 and 12? Why?
Because it's in the middle.
No, you cannot do that. You cannot see that they're in the middle because you have to count up how many people you have already counted. Remember, you have 6 students here and 14 students there. There are 60 students in all, you reach 20 students already, So look here, I told you when the data is good, you have to find the position of the median. So the position of Q2 is half of the 60, the n plus 1. Half of 60 plus 1. That's where it is located. Half of 60 plus 1. What does work out to? Half of 61 is how much?
30.5.
30.5 means you want the average of the 30th and the 31st student. See, the position of a student is a 30.5 student and 30.5 term, 30.5 student. That's what it means, 30.5 student. 30.5 means between 30 and 31. So it is the average of the 31st, the 31st student plus not the 31st, the 30th student, 30th. The 30th plus the 31st. 31st mark, or the 30th mark and the 31st mark. The 30th mark plus the 31st mark.
So, sir, it would be 12 and 13, sir.
Divided by 2. Well, it's 12 and 13. So let's look at it. You have basically have to do cumulative frequency column. Count up how many students you have as you go. And so we do a cumulative frequency column and the thing that we did today. So when you finish putting in the ones who get 8 marks, 6 of them, you have 6 students. and you put in the ones who get 9 marks. There are 14 of them. You reach 20 students. And then you have 2 students who get 10 marks. So you reach 22 students. They have 6 students who get 11 marks. So if I add the 6 students to this 22, no, so you have now 28 students. Then all the students who get 12 marks, there are 2 of them. So you reach 30 students now. So you just reach 30 students, right? So it means that the 30th student get 12. And so now, right here, so now, you put in 11 more students for the ones who get 13 marks. 11 students get 13 marks, and so you reach 41 students now. And then you put in 9 more students who get 14 marks. So you get 50 students. When you finish that, you have 50 students. Then you put in 10 more students who get 50. Then again, so you reach 60 students. So you want the student now who scored 30th student and the 31st student. So this equal to what now? Did you know equals what? Where the 30th student mark is? What is the 30th mark?
12, sir. 12.
Well, the 30th student get at 12. 12. And the 31st student get a what?
13, sir.
Good, because this is a group here, so a group here, so is the 31st to the 41st student. Make up the 11 student. Listen. The 31st to the 41st student in that group. Understand? The 31st to the 41st student. The 11 students in that group. The 31st to the 41st. You might say, all right, my subtract, I may get 10. No, but you have to include the 31st student in your subtract. So there's 11 students then. So the 31st student get a 13, get 13 marks. So this is 12 plus 13 over 2. So therefore it is 12.5 marks is the median mark. 12.5. That's a nice question. Anything else? So the probability that student chose at random had at least 12 correct answers. At least 12. We're gonna do that. At least 12. We're gonna calculate the probability that a student get at least 12. And by 60 of them, 60 students. How many of them get at least 12? Total is 60. Sum equals 60 students. How many of them get at least 12 marks? At least 12. Where are the at least 12 marks students? Look at the table from where to where.
Go back up, sir.
Yeah, tell me. At least 12 includes which rows? Which are the rows?
Sir, the fourth one to the last one, sir. My bad, the fifth one to the last one.
At least 12.
At least 12. Right.
Yeah, at least. Who are the students who get at least 12 marks? At least 12.
Sir, 2 to the 10, sir.
Huh?
Sir, the 2 to the 10, sir. From the 30 to the 60 mark.
From the what?
The 30 mark to the 60 mark.
In 2 to 12.
Tell me in terms of yes, sir. Tell me in terms of that group, yes, sir. Where along yes? Where along yes? From what to what?
Sir,
At
from the
least 12
12 to
marks.
15. From the 12 to 15.
Exactly. These are the ones who got at least 12. Because at least 12 means greater than or equal to 12. So you want the mark to be greater than or equal to 12. So how many students are there? We're going to find how many students are there. What we're going to do?
Sir,
So these
count.
are the marks. Huh?
We're going to count, sir.
So look at the table and tell me now. How many students?
Sir, 30.
30?
Yeah.
Tell me the values that we have to add. Tell me the values we have to add.
Sir, 2, 11, 9, and 10.
We have to add up these. That's equal 30, that's not equal 30. That equal 32.
Yeah.
No, that equal 32. See that?
Yes,
So
sir.
these are the students, these are the marks that are greater than or equal to 12, and these are the students over here. So 2 students get 12, 11 students get 13 marks, 9 students get 14 marks, 10 students get 15 marks. All of these students got at least 12 marks, 32 of them. So go back down. Is that right? The probability of x being greater than or equal to 12, x is the mark, is 32 over 60. I can simplify it after that. 32 over 60. But I say that?
Yes, sir.
And question done, I think, right? Yes. Yeah, it's done. But don't tell me our pie chart question. As the statistics still don't. Can we look at it? Hold on a second. All right. But I go to this question that I just did on group data.
Yes, sir.
All right. Other people not answering. Anybody good? Anybody
Yes,
want
sir.
to-
More.
Yes,
Yes,
sir.
sir. Good, sir.
Well, all right, good. So let's remember, guys, when the data is on group, I remember this thing. And they ask for the quartiles, you have to do the same sort of thing. Maybe we'll do this question again. I'll do the quartiles for you. You can tell me, from this data right now, no. Let's bring up stuff on the side. Since we're on it, let's look at understand what the interquartile range would be. Let's work it out. More mass equals better. Let's work it out. Look at the table. Let me erase this and tell me how we would find the interquartile range. We just found the median a while ago. Tell me how we calculate the interquartile range. We want the interquartile range. So since we want the interquartile range, we need Q3 minus Q1. So we need to find Q3 and Q1. Ready now? How do we find the position of Q1 first? Position of Q1. Where is Q1 position in this?
Sir, 1/4 times 60 plus 1.
1/4 of the n plus 1 term. 1/4 of the n plus 1 term. And the n is 60, right?
Yes, sir.
But I work out 1/4 of 60 is how much?
You mean 61, sir?
Yeah, quarter of 61, sorry, yeah, is what?
Sir, 15 point something.
15.25.
15.25. Yeah, 15.25. You know what that means? That means you want the student right after the 15th one, but before the 16th one. You want the average of the 15th and the 16th one. That's what they want. That's what the 15.25 means. More than 15, but less than 16. That's the terminal. That's a term. The position of it is position of Q1 is a 15.25 term. All right. Maybe there's another way to actually do it. Because remember, I think it works out itself. Because remember, if it's 60 of them there, 60, look at it this way, 60 data, right? So you have 30 and 30, right? 30 and 30. And you want to inject one in the middle for Q2. You have 30 values down here. And if you have 30 values, you have to divide it half and half again. So you're going to divide it 15 and 15 again, and then inject one in the middle again. See that?
Yes,
You
sir.
understand that?
Yes, sir.
And the same thing up here, right? So you have to go half and half. So it works out itself. And then now the position of Q3. So when I find the 15th, let's work it out. Let's work out this one. So we can say, therefore, Q1 is equal to the 15th mark plus the 16th mark divided by 2. 15th mark plus the 16th mark divided by 2. So tell me them now. What's the 15th mark on this? What's the 15th mark? 15th mark is our what?
Sir, is 9 students. Is in the 20s, sir, or something.
The 15th mark is a what?
The 50th.
The 15th. What
Oh,
the 15th
is
and the 16th mark?
14, sir. 14.
No, 14 are the number of students, boss. Talking about the marks, scores. These are the marks over
Or
here.
9.
9.
Oh, 9.
You must in the fringe group, we have 6 students, you know. Then I go, then this group, oh Lord, sorry. Then this group, this right here, we're going from the 7th student all the way up to the 20th student. So it means that the 16th, the 15th, and the 16th marks are both 9. You see that?
Yes, sir.
So that's 9 and a 9. Put them on 9. So the Q1 is a 9. Let's look at the Q3 now. Q3. The position of Q3 is 3/4 of the 60th plus 60 plus 1 term, which is what? 3/4 of 60 plus 1. Talk to me, what is that? 30 plus
Sir.
60, 5.5, right?
Yes, sir.
45.5, right?
Sir, 45.75, sir.
0.75. So it's still halfway between the 40th and the 46th, right?
Yes, sir.
So therefore Q3 is the 45th mark plus the 46th mark divided by 2. Good? That's a 45.75. Because again, if you were to divide it up like this, where is that? Mark it out, cross it out. If you were to divide the data and say, all right, it's 60 of 1 to 60. You have to divide it 30. You have to divide it 30 and 30. 30 up here, so, and 30 down here. So inject a median in the middle. And then for this 30, you have to divide it 15 and 15. You have to divide it 15 and 15 and inject one in the middle for Q1. Then up here, you have to divide it 15 and 15 again. You have to divide it up here again, 15 and 15. So you see that 45 up here, so see that? 45 and the 46 one over on the other half. So these 50 will make it 45. So you're going between the 45th and the 46th student to get Q3. These 15 will make it 45. 15, 15, 15, 3 times 15. So Q3 is the average of the 45th and the 46th student. So look at the table over here now. And tell me what is the 45th mark based on this table. What is the 45th mark?
Sir, 14, sir.
Good, because when you finish right here, so you reach 41. And then now this 9 take it from the 42nd mark up to the 60th mark. So it means that both of them, again, fortunately for you, are 14, right?
Yes, sir.
Both of them are 14. So this becomes Q3 then is equal to 14 plus 14, 14 plus 14 over 2. And then based on that now, let's move this down. Based on that now, we can get the interquartile range. The interquartile range, therefore, the IQR becomes 14 minus 9. 14 minus 9 is how much?
5, sir.
That's 5. And the semi-interquartile range becomes what? What's the semi-interquartile range equal to?
Sir, 5 plus 5 divided by 2.
No, semi just means half. Semi-interquartile range means
0.5,
half
sir.
of it.
2.5, sir.
Means half of the interquartile range. So it equals the interquartile range over 2, which is 5 over 2, which is 2.5. That will be the
Yes.
semi. All right, so we just did a nice ungrouped data. So I want you all to remember this. I think I sent you this paper already, right? I sent this paper in a group already. Let me check. I think I did it. I think I gave you this paper before. Let me just check it. Let me see. I think I've given you this paper. 2021. Let me see quickly. 2021. Yep, it's there. Let me send it again. I want you guys to redo the question on this paper for me, please. 2021. All right, so let me just share it again in the group right now. Let me send it to you again in the group right this minute. Fine. So I just sent it to the group. I want you guys to redo this question by yourself. Come on, please. All right, because we don't have a lot of these to practice from. So let's do this one for me and also do the calculation that I did. So even though it didn't ask for the interquartile range, I want you still to calculate it for me. Do it over again. Go about the table right here so you can know the position of the values. All right, and then the cumulative frequency values column so you can count up how many values you have. All right, and do this calculation for the median, do the interquartile range calculation for this question. If you practice from this one, whatever you do on this one, you get another ungrouped data question to do. It is the same approach. You just need to identify what is the score and what is the frequency. These are the scores. These are the frequencies. All right. Very good. But okay.
Yes, sir. Yes,
Yes,
sir.
sir.
All right. All right. I send it to the group. You come on, please, please, please be obedient and do it. Please, please, please do it. Do it. You don't want what's coming on the exam paper, so we have to practice. You don't get a lot of ungrouped data questions. All right. If I bring up some past papers right now, you're gonna see that the majority of them is group data. The majority is group data. You'll see it. Right? If I just randomly bring up any paper, right? This is January 2022. Just did this.
Sir, so the one where we just do, sir, is a ungroup.
This is an ungrouped. The data is not grouped. See there? The data is listed ungrouped. That's what I mean by ungrouped, you know, when the data is listed. I just gave you a group a while ago where you can see they give you a range of values in the table. See a statistics question here, but this is for group data. Right? See that? So I tell you how they're presenting the data nowadays. So I told you, this is January 2022. From 0 to 0.5, from 0.5. So these are the boundary values. So start to give you boundary values now. Instead of giving you limit values, I tend to put in boundary values in tables from the other day. That's it. So this question, we'll get to this question eventually. The FX column here, which really is a sum column. Remember, FX is a sum column. You multiply this by this to get the sum, but we'll eventually get to if this question. That's January 2022. Let's look at another one. Let's look at no, there was no exam in 2020. So we can answer January 2020. Let's look at a June paper. Let's look at a June, the more recent June that we can see. Say June 2019. Is up in there. June 2019, May 2019. Let's see what they said in May 2019. Just look at it a while ago, did we? We did a statistics question on every exam paper, almost every exam paper. Right? And it's positioned in the same place on the paper every year. Always at the same question. All right. See here. This is group data. It's a group data question right there. Data is group. And the funny thing about this one, they give us a cumulative frequency. Hardly ever do that. Most times they give it a frequency, but this time they give it a cumulative frequency. So they're adding up the frequency already. So what you have to do to get actual frequencies is subtract. You have to subtract these. Look how down the group data yet. you know, I won't get into this question, but see, they're asking us for these questions, the lower boundary that we did today, class width, see, they ask those things that we just did earlier today. So they're saying for this class, for the 21 to 20 class, 21 to 30 class interval, determine the lower boundary. The lower boundary of this class will be 20.5. What is the unit of the measurement? Liters, 20.5 liters. Simple as that. The lower boundary. The class width. These values going up by 10. See it? So I know the class width is 10 now. These values are also going up by 10. So I know the class width is 10, but that's the short calculation. It is the upper boundary minus the lower boundary. So it will be 30.5. That's the upper boundary of this class, you know, minus the lower boundary of 20.5. And that will be equal to 10 liters. 10. Plenty people will make the mistake and do 30 minus 21, you know, and get 9, which is a big wrong bang. Don't subtract the limits, subtract the boundaries to get the width. See anything else? How many students recorded that? All right, so this now we have to break down the table and get that, because of the difference between the values. Because they gave you the cumulative frequency and not the frequency. So you have to put in a frequency column and work out the values of frequency. Very important. The question didn't give you a frequency. Most times they give you a frequency, but to find the frequency value, you have to just subtract these, just keep subtracting these. All right, but we don't do this yet, so we're gonna practice. We'll do group data, we're gonna do some more and see what is what. Okay, guys, but I'll stop it there for today. But most of the questions are group data, most of them. Let me say 2018, quick, 2018. Let's see what was in 2018. Quick and fast. Quick and fast. Quick and fast. This is where that's in a guide. I'm to learn how to know what's coming on the exam. To practice from the kinds of questions that will appear in the exam. So this one I give a line graph. For this one. Give a line graph. Let's see. There's a pie chart I gave in this exam. This one I give a pie chart. See? You have to read information from the pie chart. So we'll eventually do all these questions. Don't worry yourself. We will be doing all these questions. Then they gave a line graph. No, they gave a frequency polygon. Started a frequency polygon. So it shows a frequency polygon. But it's not right because it's supposed to be closed. So it's supposed to close down here at this end. It's supposed to close it by joining this end down here. So go to that point and this point over here. That's a proper thing to do. Close it there. Understand? Yep. This is a frequency polygon. 5 teams because 0 goes. The modal number of holes. And with the highest frequency, the modal number of holes is 1. One of the highest frequency. All right, guys, we'll do these things and stuff to practice after we're finished. The notes part of it, we're gonna practice a lot of statistics questions in the past papers and drill down. All right, so don't worry yourselves. All these things will become very easy just now. Very, very easy. Easy. All right, guys, I'm gonna end it there today. Go over the question for me, please. And we'll pick it up back on Sunday. For Saturday, same thing. I would like to have a session in the morning. Saturday, maybe 9, 10 o'clock. Well, not 9, 10 o'clock. 10 or 11 o'clock. So I don't know the exact time yet. I send out the link as usual and send out the notification as usual. I will try to have a session where we actually just practice some questions from a past paper. Who knows? We might just do some statistics, the ones that are not grouped. So like the pie chart we looking at a while ago. Yeah. Might just do that, or I might do a past paper as usual and get some revision. All right. Let us see. I'll decide what we're doing on Saturday. But Sunday we're coming back to the statistics. I'm gonna continue with the group data. And then once we finish with the notes, then it's a matter of practicing a lot. That's what it's gonna be about. Practicing a lot. All right, and get this topic under our belt. And then we'll have that one topic left to do, and then everything else, all other topics to do, we'll do them by example. It's not that we're gonna come with notes and PowerPoint slide or anything like that. We'll do those other topics by example, and we're getting closer and closer to doing the SP as well. All right, so see you all Saturday morning. That's the plan. Okay, bye.
Yes.
Bye, everybody.
All right,
Bye,
sir.
sir. Bye.
Later, sir.
All right, cool. Bye-bye.
All right, bye, sir.
Bye-bye, everybody.